Hello, my dear students. How are you today? Today, inshallah, we're gonna start chapter 4 for primary 3 lessons from 31 to 35. Let's start with polygons. What are polygons? Polygons are two-dimensional shapes. It means 2D shapes. 2D shapes we studied in grade 2. These are the shapes that are flat and has no volume. We can't open it or catch it or hold it. It's like our paper. We can just see them flat on the paper. So polygons are 2D shapes, straight sides only. Polygons have straight sides only. It means no curves in them, and they are closed shapes. To understand more, we will take some examples. Here, the first shape, it's polygon or not? Is it polygon? Huh? It's two-dimensional shape. It's straight sides only and no curves, yes? But it's not closed, it's open. So, it's not polygon. Number 2, 2D shape, straight sides only and closed shape, so it's polygon. Number 3, is it polygon or not? No, it's not polygon. Why? Because it's curved. It's not a shape that has straight sides. Number 4, is it polygon or not? No, it's not polygon because here we have a curve, so it's not polygon. Number 5, yeah, it's polygon. It's 2D shape, straight sides and closed. Number 6, it's not polygon because it's open shape. Opened shape. Here we have some polygons. We want to count their sides and their vertices and focus well with their names. The first shape is triangle. Triangle. It has 3 sides and 3 vertices. The second shape is square, and square is called quadrilateral, and we will see later what are quadrilaterals. And it has 4 sides and 4 vertices. The next one is pentagon. Pentagon, which is a polygon, and it has 5 sides and 5 vertices. The next one, hexagon. Hexagon is a polygon that has 6 sides and 6 vertices. The next one, heptagon. Heptagon. Heptagon is a polygon that has 7 sides and 7 vertices. The next one, octagon. Octagon. Octagon is a polygon that has 8 sides and 8 vertices. The next one, nonagon. Nonagon. Nonagon is a polygon that has 9 sides and 9 vertices. Decagon. Decagon. Decagon is a polygon that has 10 sides and 10 vertices. We studied all of them in the last year except heptagon, octagon, nonagon, and decagon. Now let's move to quadrilaterals. Quadrilaterals. It's very long word, and here our friend will help us to cut it and read it easily. Quadrilaterals, quadrilaterals, quadrilaterals. What are quadrilaterals? Any shape has 4 sides and 4 vertices is called quadrilateral. Like what? Here we have square, rectangle, trapezium, parallelogram, and rhombus. Parallelogram and rhombus. Parallelogram is our new shape this year. And all of them are called quadrilaterals. It means all of them has 4 sides and 4 vertices? Yes, let's see together. Here in our square, 1, 2, 3, 4. My rectangle, 1, 2, 3, 4. And trapezium and rhombus and parallelogram. All of them have 4 sides and 4 vertices. Let's see vertices together. 4 in square, 4 in rectangle, 4 in trapezium, and 4 in rhombus, and 4 in parallelogram. So all of them are called quadrilaterals because they have 4 sides and 4 vertices. So any shape has 4 sides and 4 vertices is called quadrilateral. Now let's apply to our shapes. Here we have some shapes and we want to name them. The first shape is triangle, triangle. Second one, square, square, square. The third one, rectangle, rectangle. The fourth one, trapezium, trapezium, trapezium. And we called it in the last year trapezoid, and both of them are correct. So it can be called trapezium or trapezoid. The next one, circle, circle. The next is parallelogram, parallelogram, and it's a new shape this year. Parallelogram, parallelogram, parallelogram. And this parallelogram has 4 sides and 4 vertices, as we said in quadrilaterals, and each 2 opposite sides are parallel and equal. And the next one will be cube, cube, cube. And the next is rhombus, rhombus, rhombus. And number 9, hexagon, hexagon, hexagon. Number 10, octagon, octagon, octagon. Now let's move to some categories and title them or name them and see what in each category. The first category is 4 vertices and it has square and rectangle. What else? Rhombus, parallelogram, and trapezoid. All of them have 4 vertices. The next category is 3 vertices that has triangle, triangle. The next category is 6 vertices. It has hexagon, hexagon. And the next one, 7 vertices. It has heptagon, heptagon, heptagon. I know heptagon is not included here in our shapes, but we studied it in the previous slide, and I want you to use it to memorize it and study it well. The next category is 8 vertices, which is octagon, octagon. And the last one, no vertices. We have here circle, circle. Now our challenge. Let's write the attributes of each shape from these 3 shapes. The first shape is polygon or not? Yeah, it's polygon. It's 2D shape and closed one, and it doesn't have any curves. So it's polygon that has 10 sides and 10 vertices. The next one, it's polygon also, and it has 5 sides and 5 vertices. The last one, it's polygon or not? No, it's not polygon. Why? Because it has some curves, right? Yeah, so it's not polygon. Now, we have here 3 shapes. Um, 2 are polygon and 1 is not polygon. Could any of these shapes fit into one of our categories? Yeah, we have here our cylinder that belongs to no vertices category. Now our math journal. Reflect on your learning. In your own words, explain a polygon. Yeah, we have polygon, which is 2D shape, straight sides only, which means no curves included, and closed shapes. For example, we have here rectangle and square. Both of them are polygons. And let's explain parallelogram. Parallelogram is 2D shape, which is quadrilateral. It means it has 4 sides and 4 vertices. We said quadrilateral means 4 sides and 4 vertices, and each 2 opposite sides are parallel and equal. Now let's move to lesson 32. Lesson 32 is a revision on multiplication. So I will leave it as a homework for you, but just remember, we will write in the first column number 2 as a factor. So we will multiply all these factors with 2. And the next column, we will multiply these factors by 3. And the third one we will multiply with 4 or by 4. So it's a homework for you to revise the tables. Lesson 32. Here we have Venn diagram. Venn diagram is a strategy we use to sort our shapes. We will sort our shapes according to some features or some attributes. I will write it. In the first circle here, we have more than 3 sides only. So from these shapes in the right paper or in the right page, we will pick only the shapes with more than 3 sides and put them in the first circle. In the next circle, we will put the shapes that have each 2 opposite sides are parallel. Only the shapes with each 2 opposite sides are parallel I can put here in the second circle. But focus with me. Between 2 circles, we have here intersection area. This is called intersection. Intersection means it's the space we will put the shapes that follow the first attribute and the second. It means we will put in the intersection area the shapes that have more than 3 sides and also opposite sides are parallel. So I will put here the shapes which are common between these 2 circles. Let's see together. We have here some shapes. The first shape is rectangle. Why I put it in the intersection area? Because rectangle has more than 3 sides. Yes, it has 4 sides. So it's more than 3 sides. Also, each two opposite sides are parallel. Each two opposite sides are parallel. So it follows the first circle and the second one. Where should I put it? I will put it in the intersection area. The second shape is square. Yes, square is more than three sides. Okay, where should I put it? Does it follow each two opposite sides are parallel? Yes. In square, we have each two opposite sides are parallel. So it follows the two circles, both of them. It follows the two features. So I will put it in the intersection area. The third shape is parallelogram. Parallelogram also more than three sides and opposite sides are parallel. So I will put it in the intersection area. The fourth shape is rhombus. And rhombus is more than three sides and also each two opposite sides are parallel. So I will put them in the intersection area. And the next one, trapezium. Trapezium, more than three sides. But focus here. In trapezium, each two opposite sides are parallel? No. So I will not put it in the intersection area. It's only in the first circle. Also, don't forget these shapes. These shapes are more than three sides, but not each two opposite sides are parallel. So I will put them up here with trapezium. Lesson 33. First, we will start with a warm-up about trapezium. And we studied trapezium or trapezoid in the last year, and we said trapezium is a 2D shape or polygon that has four sides and four vertices, and these four sides, two are parallel and two are not parallel. And we said parallel means cannot meet. So each trapezium has two sides, two can meet, so they are not parallel, and two can't meet, never can meet. So it's parallel. So let's write the definition of trapezium. Trapezium is a quadrilateral that has four sides. Two are parallel and two are not parallel. And we said parallel means cannot meet. Here we have two pages filled with shapes. And we have here in the page 87 a graph that shows number of shapes: rhombus, rectangle, parallelogram, trapezium, and square. Let's start with rhombus. How many rhombuses here? 1, 2, 3. So we will draw a column or color the column of rhombus till 3. The next shape is rectangle. How many rectangles here? Yeah, 1, 2, 3, 4, 5. And let's color the column of rectangle till 5. Here, parallelogram. How many parallelograms? Only one. It's colored with green, so we will color one. Trapezium. How many trapeziums here? 1, 2, 3. So we will color the column of trapezium till 3. Let's go to the last shape, which is square. How many squares here? 1, 2, 3. We will color square column 2, 3. Tell 3. Now let's move to the area. The area is the space or number of squares inside the shape. Each square inside the shape is called square unit. Okay, what does it mean? I didn't understand. Let's see an example. Here, in our example, we have a rectangle colored with blue. This big rectangle colored with blue, it has some squares inside it. If we counted these squares inside this rectangle, we will find them 15. So the area of this rectangle is 15. So how to find the area of any shape? Area can be found by two ways. First way, counting squares inside the shape. We said that this blue rectangle is our shape. And if we want to know the area of this rectangle, we will count the squares inside it. How many squares inside it? 15. So we call each one square inside it unit square. So all of them are 15 unit squares. Number 2, we can find the area by multiplying rows by columns. If we considered that this rectangle is like our array, so we can find the area or the total number of squares by multiplying rows and columns. How many rows here? 3. We have 3 rows. How many columns here? 5. We have 5 columns. So if we multiplied 3 by 5, 3 is multiplied by 5, or 3 times 5 equals 15. 15 what? 15 square unit. So the area is 15 square unit. Let's apply to our area. We have lesson 34. We have here some story problems, and we will read them carefully and find the total area for each garden and draw them. First, Jana is planting squash. Each squash needs 1 square unit. So, each one squash needs 1 square unit. She would like the garden to have 2 rows with 9 square units in each row. So, we have 2 rows, and inside each row we have 9 square units. How many squash can she fit? If we want to find the total, we will multiply 2 rows with 9 squares. So 2 times 9 equals 18 squash. Let's draw them. 2 rows, and inside each row we have 9. So the total area is 2 times 9 equal 18 square units. Number 2, Omar wants to plant corn. Corn needs 1 square unit of space. So corn needs 1 square unit of space. He would like the garden to have 3 rows with 7 square units in each row. So 3 rows with 7 square units, it means 3 times 7 equals 21. Let's draw them. Yeah, we have 3 rows here. Each row contains 7 square units. So the total area is 3 times 7 equals 21 square unit. Number 3, Yusuf loves watermelon and he wants to plant it in his garden. Watermelon needs 1 square unit of space. He would like the garden to have 4 rows with 4 square units in each row. So, how many watermelons can Yusuf fit in his garden? He wants 4 rows, and inside each row 4 square units. So 4 times 4 equals 16 watermelons. Let's draw it. 4 rows, inside each row 4. So the total area is 4 times 4 equals 16 square unit. Number 4, Nadia wants to plant zucchini. Zucchini needs 1 square unit of space. She would like the garden to have 3 rows with 4 square units. So 3 times 4 equals 12 zucchini. And we will draw it. 3 rows with 4 square units. Yeah, like this. The area will be 3 times 4 equals 12 square unit. Number 5, the last one. Aya wants to plant lettuce. Lettuce needs 1 square unit of space. She would like the garden to have 5 rows with 8 square units in each row. How many lettuce can Aya fit in her garden? 5 rows with 8 square unit. It means 5 times 8 equals 40. To draw it, we will draw it in the next page. Here we will draw the garden, which is 5 times 4 times 8 equals 40 square units. Let's go to our challenging part. Number 1, if Jana, Omar, Yusuf, Nadia, and Aya all put their gardens together, what would be the total area? How many total square units would they need? The total area can be calculated if we added all previous areas. So if we added 18 plus 21 plus 16 plus 12 plus 40, all of them equal 107 square units. So this is the total area, 107 square units, and they need 107 square units for the total garden. Number 2, Hiba has 2 rectangular gardens, one for lettuce and one for squash. The squash takes up 12 square units and the lettuce takes up 10 square units. What could her garden looks like? And remember, the garden are rectangles with the same number of square units in each row. Draw gardens below and they must fit in the grid paper. First, the garden, which is 12 square units, will be like what? Here we have the total area, the total number of squares. So 12 will be what times what? If we said we have 2 rows, 2 times what equals 12? 2 times 6. So we will have 2 rows times 6. Each row contains 6, like this. And the total area will be 12 square units, 6 times 2. And the next garden, the total area is 10 square units. 10 equals what? If we said we have 2 rows also, 2 times what equals 10? 2 times 5. So we have 10 square units like this. Our math journal. How is finding the area of garden plot similar to solving multiplication? Explain your thinking. We will say finding the area or the total number of squares in a rectangle can be calculated as an array. So the area equals rows times columns, as we did before. Lesson 35. Look at the puzzle below and how many rectangles can you find? How many colors or number of them? Let's find our rectangles. The first one here in blue, the second in red, third in green here like this. This is fourth, baby blue or light blue. This is fifth, which is yellow, and then the black one and the gray one, and we have here brown one and light blue one. Total rectangles are 9 rectangles. Here in lesson 35, determine the area of each rectangle. Explain the strategy you used. If we wanted to find the total area here, we can multiply or count. We can count the small squares inside this first rectangle, or we can multiply rows by columns. How many rows here? 1, 2, 3, 4, 5, 6. We have 6 rows. How many columns? 1, 2, 3. So we can say the total area equal 3 times 6 equals 18. Rectangle number 2, we have here, as we can see, we have here 8 columns and 4 rows. So 8 times 4 equals 32. The third rectangle, we have 7 columns and 10 rows. So 7 times 10 equals 70. By the same way, we can find rectangle number 4 and number 5 and number 6. Now let's move to the challenging. Here we have a garden and we want, in this problem number 1, we want to find the total area. I think the easiest way is to count the small squares. Let's count them together. If we count them, we will find them 30 square units. And in rectangle number 2, if we count the small squares, we will find them 21 square units. Thank you for watching and goodbye.